Philippines is no stranger to storms. The country's group of islands weathers around 20 storms and typhoons a year. But when news of super typhoon Goni was announced, the Philippines took action, preparing itself the best it could under the restrictions of COVID-19. 390,000 people were evacuated from their homes as 2020's strongest storm hit the archipelago on the 1st of November. It was the most powerful typhoon to make landfall on the islands since 2013, when Typhoon Haiyan killed at least 6,000 people. As Goni left devastation in the Philippines, another storm was brewing on the other side of the world. Hurricane Eta bore down on Nicaragua, damaging homes, tearing down power lines, and causing flash flooding. 2020 has seen more storms from the Atlantic Ocean than ever in recorded history. You're listening to Beyond the Headlines. I'm Sulaiman Hakimi, and this week, we're looking at why climate change means storms are getting worse every year. Tropical storms are given categories based on their wind speed. Different countries have different category systems and names. These categories rate a storm from weakest to strongest, but even a weak storm can be dangerous. This year, for only the second time ever, the U.S. National Hurricane Center ran out of names for tropical storms and hurricanes. The naming system goes through the alphabet, missing out the letters Q, U, X, Y, and Z. 21 letters were taken, ending in Hurricane Wilfred by mid-September. The center then turned to the Greek alphabet for more names. We spoke to Bob Ward, Policy and Communications Director at the Grantham Research Institute on Climate Change and the Environment, part of the London School of Economics.
What research is showing is that the frequency of strong tropical cyclones around the world has been increasing over recent decades. In most of the basins, there's been a recorded increase, including the Atlantic. It's a bit more complicated in the Western Pacific, but this is what we would expect from climate change. And the reason for that is because we know that the primary fuel for tropical storms is warm sea surface temperatures, and global warming is causing sea surface temperatures to rise, and therefore the strength of storms is tending to increase.
Not only are the storms becoming more frequent, but the intensity is increasing. Climate change, or more specifically, global warming, is contributing to this increase. Hurricanes, typhoons, and cyclones are all different names for tropical storms, the only difference being which ocean they originate from. So let's take a look at what we know about how tropical storms form. When ocean temperatures reach at least 26.5 degrees Celsius, heat rises from the sea. This most often occurs close to the equator. This rising air condenses, cools, and towering clouds form. This creates an area of intense low pressure that sucks air in and causes strong winds. The spin of the Earth directs the wind into a vortex. In the case of Goni, the wind sustained speeds of 225 kilometers per hour. When tropical storms cross land or enter colder climates, they lose momentum.
But remember that from the climate's point of view and from the atmosphere point of view, tropical cyclones are a way in which you transfer energy from the oceans into the atmosphere. It's a way of transferring heat from the oceans to the atmosphere. And so it's an important process for regulating the overall climate and is therefore an important part of it.
Bob explains how climate change is making the three main dangers of a tropical storm worse: high winds, heavy rainfall, and storm surges.
We know that the warming atmosphere means that it is holding more water, which means that tropical cyclones now are tending to create even higher amounts of rainfall. And that's been a particular feature seen in the United States. Hurricane Harvey, which hit the coast of Texas a few years ago, had record rainfall, and there is a trend there that we can see an increase in rainfall. The way in which climate change is affecting tropical cyclones is it's causing sea level rise, which means that the height of storm surges, which can be really devastating, that height is increasing because sea levels are going up. Strength, the amount of rainfall, and the size of storm surges are all increasing as a result of climate change.
Rapid intensification is a phenomenon that has begun to emerge in the last few years that sees tropical storms suddenly gather intensity very quickly.
There was an expectation based on modeling that we would see these things happen. There are lots of global models that suggested that we would see overall, as we go on through this century, as a result of climate change, fewer tropical cyclones overall, but more of the strongest tropical cyclones. And it was a key paper published earlier this year in May that showed that we can now see a trend in many parts, many basins of the world towards the stronger tropical cyclones. And so that is something that's just started to emerge. In the last couple of years, there's been key research showing, particularly in the Atlantic basin, this process called rapid intensification, where storms very quickly go from being weak to strong.
Storms that rapidly intensify like this are less predictable, even though we are better at forecasting. This can be more deadly. Over the last 30 years, the number of storms that become powerful hurricanes has tripled. Dr. Tom Matthews is a lecturer in climate science at Loughborough University in the UK.
Generally, what we tend to see in climate model simulations is that with greater warming, the average intensity moves upward. So the tropical cyclones become more intense, and on average. And that suggests that, yes, we should expect to see tropical cyclones emerge that are stronger than anything we've seen before. On average, we're talking about relatively modest increases in intensity if measured through maximum wind speeds. We're looking at around 5% is the sort of consensus number, but there's a relatively big spread around that consensus number. But what's important to appreciate is that when the wind is moving very fast, small increases can translate into very big increases in damage and total energy. So a 5% increase in wind speed translates to almost a 16% increase in power.
Bob Ward explains these storms are not confined to the tropics.
If you look at a country like Bangladesh, for instance, which is low-lying, it's in areas that can be vulnerable to these very strong storms. Sea level rise and strong storms are a real threat to a large part of the country, and you need to have a recognition that they are going to be particularly affected. And for them, this is really a battle of their existence. But even rich countries, they're under threat. A very major hurricane hitting Miami head on, Category 5 hurricane hitting Miami, would cause hundreds of billions of dollars of damage, perhaps even reaching $1 trillion. That would cause disruption to lives and livelihoods that could have major impacts on the US economy and could affect the global insurance industry. There's a lot of insurance money in Miami, and if it was hit by a Category 5 hurricane, it would be a major event for the global insurance industry that would probably require premiums to go up for coverage around the world as a result. So we could possibly bankrupt the state of Florida, and as I said, would have a major impact on the US economy. So even rich countries are not going to be immune to these impacts and need to take this threat very seriously.
Similar to tropical storms are extratropical storms, which form in more temperate areas away from the equator. Dr. Matthews explains that while these areas don't experience the intense winds of hotter regions, they see heavier rainfall.
What we call extratropical cyclones, don't necessarily expect those to become more intense in terms of the wind speeds as the climate changes. And those afflict or impact the temperate northern latitude and southern latitudes, what we would call the mid-latitudes. We don't necessarily expect those to become more intense as the climate warms. But some features of them, like how much rain they drop, we do expect to become more intense because of the fundamental physical connection between a warmer atmosphere and more water holding capacity and more intense rainfall as a result. So there are some climate hazards that are more nuanced and in their response to climate warming, but others that are very robust. And the robust ones are extreme rainfall events, extreme heat.
And as the heat continues to rise, countries or cities with lower tolerances and less infrastructure to protect against it will also be affected.
the more temperate areas of the world, if we were to class Europe and parts of North America as more temperate, can point to several examples of weather events that have been extremely disruptive and deadly. So, for example, in Europe in 2003, Europe is not known for being one of the hottest parts of the world, but it still recorded a heat wave. Russia in 2010 experienced a heat wave. Now, I know we're focusing little on extreme heat here, but it highlights, was a very good example of a relative excursion. So these temperatures are not record-breaking in a worldwide sense when they strike, but they are unfamiliar to the populations that are experiencing them. And that means they have very big impacts. And it's worth reflecting on that point overall. The point being that our societies, our infrastructure, reflect or are built to deal with the climates that we've grown in, if you see what I mean, the environment that our society has been has flourished in. So be that things like our river flood defences, they are built to a certain standard reflecting the past climate stresses. Our buildings are built to a standard to be thermally optimal given the past climate. In Europe, for example, we tend to have buildings that are quite, we emphasise thermal efficiency, places that can keep warm in winter. Now, as the climate changes, all of that traditional building and all of our traditional infrastructure is stressed in a way from the new climate it encounters. Warmer summers that now mean those houses that were built to keep warm in the winter are now dangerously warm in the summer. Our flood defences may no longer be high enough to keep the floodwaters out, given increases in precipitation and extreme precipitation events. So temperate regions do not escape unscathed.
The heat waves mentioned by Dr. Matthews killed tens of thousands of people in Europe and Russia. So what can be done? Here's Bob Ward again.
Climate change, unfortunately, is locked in for the next 3 or 4 decades. The climate will continue to get worse in terms of these extreme weather events. And so we are going to have to learn to adapt and become more resilient. And that is a combination of factors. We are already seeing, for instance, better use of early warning systems that allow you to evacuate populations before they're hit by tropical storms and tropical cyclones. And that has helped to reduce the number of deaths that you see associated with them. But there is a question of whether we should be now moving communities away from low-lying coastal areas which are prone to these tropical storms. And you can try and defend them by building stronger buildings and building higher flood defenses. That is going to be what's happening in where we've got major cities built on coastlines, Mumbai, Shanghai, cities like Miami. You can probably build stronger and higher to defend yourselves. But for other communities where it's not feasible, there is a question of where you want to relocate populations away from the coasts because they will just become too difficult to be resilient to. And that will require very major changes in how we think about economic development and economic activity along the world's coastlines.
Although building defenses against tropical storms is pragmatic, Dr. Matthews sees further complications ahead.
Traditionally, when I say traditionally, I mean under the current climate or the climate of the recent past, it can be quite difficult to sustain heat waves and hurricanes at the same time of year because heat waves tend to strike in midsummer or early summer when the sun is high in the sky and the land is heating up really quickly. Tropical cyclones tend to come, as we're seeing now, at the end of the summer and into the fall, into the autumn. Now, as the climate warms, it's then warm enough further into the fall, further into the autumn, it's warm enough for dangerously hot conditions to still be encountered on land. And that now coincides with the peak hurricane, tropical cyclone frequency. So we can start to see these new interactions emerging. To summarize that sort of more broadly around extreme weather and research interests, what I'm particularly interested in, and what I think society should be interested in or concerned about perhaps, is the emergence of novel threats, so novel climate threats that we have, I suppose, little appreciation of because all of our understanding is based on climate of the past, which is not the world that we're moving into. And The world that we're moving into, yes, it means more of the familiar, but it may also mean some novel threats out there, like the interaction of climate hazards in a way that we haven't seen before. And research in this field is evolving rapidly.
Tropical storms are becoming stronger as global temperatures increase. Although these massive storms do redistribute the energy from the sea and regulate the climate, they are calamitous for human populations.
Tell me about how your house fared during Laura.
It didn't fare in the back. I had a tree limb fell in my bathroom, and the whole tree fell on my roof in the back. The back part of the roof is damaged bad. Got a hole in my back bedroom and bathroom.
A particularly vicious storm in a precise location could have global ramifications on human life, social infrastructure, and economic systems. As global warming continues to increase, there is realistically only one solution.
But in the long term, if we want to avoid the possibility of stronger storms that are just simply too difficult to deal with, even for well-defended areas, we do have to reduce our emissions. Global emissions have to go down to zero, effectively to zero, because it is only when they get effectively to zero that climate change will stop.
I'm physically and mentally tired. I worked hard for what I have. I work for what I have. I've been working since I was 18. And material things are not everything, but just the fact that you have to start all over. So now it's going to be a little rougher.
Thanks this week to Bob Ward and Dr. Tom Matthews. You've been listening to Beyond the Headlines. I've been your host, Sulaiman Hakimi. If you've enjoyed this episode, please subscribe by clicking the subscribe button in your favorite podcasting app. And you can also leave us a review to let us know what you think. This episode was produced by Daniel Bardsley, James Haynes Young, Arthur Edison, Aisha Khan, and Erica El-Kershi.